All right, good evening. You're welcome to today's tutorials with From Eternity the Schoolboy. Today we are going to take a look at chemistry. In our last class in chemistry here, I gave you an assignment to write a short note on the vulcanizer's solution, and talk about the uses, the component of vulcanizer solution and what the uses. So I don't know. So what did you do? Come, let's hear what you did. Okay. So what did you do on vulcanizer solution? Okay. Is what? Okay. So what is this? What is vulcanizer solution?
It is a chemical mixture, usually has sulfur and other cross-linking agents.
Okay, it has what? Sulfur and other cross-linking agents. Did you bother to find out those cross-linking agents?
The cross-linking agents, phosphorus,
Rubber. That's all. Okay. In a nutshell, what are list the components of vulcanizer solution? List the components.
phosphorus,
Vulcanizer's solution. Phosphorus. Rubber. What else? Sulfur. What? Benzene. Is that all? These are the components of what? Vulcanizer's what? Solution. Okay, what is the application? What is it used for?
making rubber strong.
Making what? Rubber strong. Is that all you able to do in vulcanizer solution? Okay. Go and sit down. I am working when I come out here. Keep your bag and come. What did you do in vulcanizer solution? Come closer. Let's hear you. First of all, what is what do you understand by the term vulcanizer solution?
Vulcanizer solution is a chemical mixture. Usually has sulfur or other cross-linking agents. Accelerator and activator.
It has what?
Accelerator and activator. The main job of the vulcanizer solution is to start and speed up the process of vulcanization. Vulcanizer solution contains phosphorus, rubber, benzene, and sulfur. Hot vulcanizing solution is formulated as a liquid vulcanizing agent suitable for rubber bonding purposes.
Okay.
The vulcanizer solution is prepared by dissolving rubber in benzene.
So the main thing there is what? Rubber and what? Okay. Is that all? Are you sure rubber and benzene are the main thing there?
Yes.
Are you sure? Is that all you did? All right, thank you. So if you come across this thing in JAM now, at least you'll be able to answer the question, right? Yes. JAMB like the question. They may ask you to do what? List but the way they will ask it, they will not tell you the list. They will just put it in option. Get the what? The components. Then another thing I want to find out is this: what classification of matter is vulcanizer's solution? What classification of matter does vulcanizer's solution belong to? What are the classifications of matter? What are the classifications of matter? Liquid? No. You are talking about states of matter. Hello? Components of matter, states of matter, and the classification of matter are not the same thing. Am I communicating? Component of matter, state of matter, and the classification of matter, they are not the same thing. If you are talking about solid, liquid, gas, you are talking about the states of matter. If you are talking about ions, atoms, molecules, you are talking about what? Component of what? Matter. So what are the classifications of matter? Elements, mixture, and compound. Hello? Please, don't confuse these things. A lot of people confuse these things. Please be careful about it. States of what? Matter is what? Solid, liquid, and what? Gas. Am I communicating? Components of matter. Components of what? Matter. You talk of what? Atoms, ions, and what? Molecules. Classification. Of matter. You have what? Elements. Compounds. And what? Mixture. Does it make sense? Please don't confuse these things. Okay? They're not what? The same thing. This one is state of matter. This one is what? Components of matter. This one is what? Classification of what? Matter. Today is 11, not 12. Sorry. Today is 11, not 12. Please do not confuse these three things. These three. States of matter, component of matter, and what? And what? And what? Classification of what? Matter. We will discuss state of, anyway, it's good I mention it. Matter can exist as what? Solid. It can exist as what? Liquid. It can exist as what? Gas. Am I communicating? These ones, solid can change to what? Liquid. How can solid change to liquid? By what process? What happens? By what? By liquefaction, right? Either by heating it, right? Mainly, it will turn to what? Liquid. Liquid can change to gas, right? By doing what? By heating it, right? Good. At high temperature, liquid can become what? Gas. And the gas can go back to what? Liquid. By process of what? Gas can go back to liquid by process of what? Condensation. Through condensation, gas goes back to what? Liquid. Then through solidification. Through what? Solidification. Example of that is freezing. liquid can go back to what? Solid. Through solidification, liquid can go back to what? Solid. So these are the states of what? Matter. These are the what? States. These are the what? States of what? Matter. Now, component of matter. Component of matter, you have what? Atoms. As what matter contains. Am I communicating? What matter what? Contains. This is the state form. This is state. This state of matter means different form in which matter can do what? Appear. Am I communicating? This component means what matter does what? Contains. Am I communicating? That is component of matter. Here you have atoms, ions, and what? Molecules. Am I communicating? We will still define atoms, we will still treat atoms, ions, and molecules in details. Okay? Now, when we go into the atomic structure, when we go into the what? Into atomic structure, we now start talking about what? And bonding. We start talking about what? Atoms, molecules, and what? Molecule and what? Ions. Are we together? Are we together? Good. When we go into that, we'll talk about this, okay? Now, classification of matter, we just mentioned them to prepare our mind towards that. Classification of matters. This talks about how matter, different types of matter. Am I communicating? When you classify matter, types of what? Matter. So matter can be elements. Any matter you see, it is either it is an element, a compound, or a what? Mixture. Am I communicating? Good. Now, element, we have defined element, right? Element can come together to form what? Compound. True of us? Good. And the mixture can contain one or more elements, or even element and a compound, or one or more what? Compound. This can form what? A mixture. And we will define mixture in detail. So now we'll continue from where we stopped. We talked about I want to look at the differences between what? A mixture and a compound. I'm not communicating. Let's look at the difference between what? A mixture and a what? A compound. Our reference book for today is New School Chemistry for Senior Secondary School by Oseyo Ababio, as revised by L.E.S. Abanisi. This is 2016 edition. 2016 what? Edition. Now let's go. We define mixture, right? Right? And we gave examples of mixture, right? Good. And what they contain, right? Good. Now, let's look at the difference between mixture and compound. Mixture and compound are not the same thing. You can draw a table. You can draw a table, write mixture, then write what? Compound. A mixture may be what? Homogeneous or what? Heterogeneous. A mixture may be what? May be homogeneous or what? Heterogeneous. Under compound, you write a compound is always what? Homogeneous. A compound is always what? Homogeneous. Now, see what I mean by that. You know, a mixture, when you say that something is homogeneous, when you say that something is homogeneous, what it means is that the content of that thing is the same thing all over. Let's assume now you have, or similar, you can say similar. Let's assume now you have let's assume you have salt now. Hello? Are we together? Let's assume you have salt and you put the salt in water. What will happen? The salt will do what? Will dissolve to form what? What?
Solution.
Good. If you dissolve a salt in water, salt will dissolve to form what? Solution. Now, if you bring that water containing the salt, will you be able to identify the salt? Now the salt will blend in the water that you not be able to touch the salt or see the salt. Am I communicating? That is the homogeneous what? Mixture. And it is called one face. It has one what? It is said to have what? One face. One what? Face. Am I communicating? It is said to have what? One face, because everything in the mixture will look alike. Am I communicating? You will not see any particle of the what? Salt. You will not see any particle of the what? Salt. In such case, such mixture is what? Homogeneous. Am I communicating? Now that is a homogeneous what? Mixture. You know what we say, that a mixture can be what? Homogeneous or what? Heterogeneous. Now, if you get sand and pour the sand in water, will the sand dissolve? If you bring the water containing the sand, you will still see the sand. You will see the what? See the sand. Such is not a homogeneous mixture. It's a heterogeneous what? Mixture. Am I communicating? It's a heterogeneous. It doesn't have one face. You can see the sand, you can see the water. So it has two faces, right? There are two faces, right? Now get oil and pour in water, or get water and pour in oil. With the oil, can you still see the oil? Yes, because the oil and water, oil will not dissolve in the water. Oil will not do what? Dissolve in the water. Because the oil will not dissolve in the water, it will form what is called a heterogeneous what? Mixture. A heterogeneous what? Mixture. It's called what? A heterogeneous what? Mixture. Now, such mixture has two faces. There are two faces there. The water phase and what? Oil phase. They will not mix to form a uniform. In fact, you can say that in a homogeneous substance or mixture, there's what is uniform. Is what? Uniform. There's what? Uniformity. But in heterogeneous is not uniform. You can still see the separate thing that you brought together to mix together. Now let's look at have you ever seen a flood before? Flood, right? Now flood contain a lot of things, right? Some will dissolve in it, some will not dissolve in it. True of us. Now that flood, now would you say that flood water is a homogeneous mixture or a heterogeneous mixture? Is what? You don't know. Flood water, is it a heterogeneous mixture or a homogeneous mixture? Is what? Heterogeneous. Because there are things inside that water that will not dissolve. True of us. If you put your hand in a flood, if you get out, let's say you dig a hole here, and after rain, you get out flood water inside that hole. Put your hand, you bring a lot of things out. You bring attachments, you bring out stone, you bring out nail, you bring out pin. True or false? Those things will not dissolve in the water. And because they don't dissolve in the water, that water will not form a solution. True or false? It is a mixture that is what? Heterogeneous. Now get an ink. Ink. This ink of your pen now, this ink in your pen now, open it and pour it out now. That ink, is it homogeneous? Is it homogeneous or heterogeneous? It's homogeneous. Because those things that gave that ink that color dissolves in the whatever solvent they use. True or false? You can't touch them. If you touch them, you can't feel anything. True or false? You can only see the color. Am I communicating? So is a what? Homogeneous what? Mixture. So if they ask you, if you see a question that has to do with examples of homogeneous and heterogeneous mixture, you can answer such question, right? Good. So that's why in that first difference now, a mixture can be what? We are talking about the difference between mixture and what? Mixture and what? Compound. But before then, I noticed that I know that they're having issues, that you guys were having issues with. You're confusing state of matter, component of matter, and classification of matter. So I now list the state of matter. I now listed the state of matter, listed the component of matter, and listed the what? Classification of what? Matters. So matters are classified into this element, compound, and mixture. And component of matters are atoms, ions, and what? Molecules. Components are what matter contains. They are components. While state of matter are different forms. Matter can appear solid, liquid, or what? Gases. And this state of matter can change. Matter can change from one state to what? Another. True or false? Now, that's what we also discuss the vulcanizer solution. And 2 people have done their assignment. Maybe before the end of this class, others that came late will do their own assignment. Let me hear what they did. Are we together? So after that, now we now went to what? The difference between what? Molecules and mixtures and what? Compound. And the first difference is that we said that a mixture can be homogeneous or what? Heterogeneous. So I have been trying all this while. I'm trying to explain, which I believe you understood, what is homogeneous mixture and what is what? Heterogeneous what? Mixture. Now we say that a compound is always what? Homogeneous. Do you know why a compound is always a homogeneous? A compound is a pure substance. Do you know why? The different components, different compounds or elements that come together to form a compound, they react and form bonds by chemical bonding to form a new substance, entirely new substance that is pure. So whatever that compound that is formed is an entity and is pure. There is nothing else added into the word compound. Am I communicating? That's what they say. A compound is a pure substance. Am I communicating? Because it is a new substance that is formed from chemical bonding between 2 or 3 other elements or compound. Am I communicating? So a compound is what? Homogeneous. A compound is what? Homogeneous. And let's continue with the difference between a compound and a mixture. I think I've already explained here that compounds are chemically bound together, right? Unlike mixtures. Now you can put this down. The constituent of a mixture can be easily separated and recovered by physical means. The constituent of a mixture can be easily separated and recovered by physical means because they are not chemically bound together. The component of a mixture can be easily separated and recovered by physical means because they are not chemically bound together. Because they are not chemically bound together. And then that is for what? Mixture, right? Now, are we together? Now go over to compound. The component element of a mixture of a compound cannot be separated by physical means. The component element of a compound cannot be separated by what? Physical means. Why? Because they are chemically bound together. Because they are chemically bound together. Because they are chemically bound together. Now let's go to the number 3 difference. A mixture cannot be represented by a chemical formula. A mixture cannot be represented by what? A chemical what? Formula. Do you know the reason? Do you know the reason why a mixture cannot be represented by a chemical formula? I said this in this class. Do you know the reason? Who knows the reason? Who knows the reason? You don't know? Who knows? No. Even though it led to it, but it's not the main answer. Who knows? Festus, do you know? Chima, do you know? Sit up. Now let me explain. A mixture cannot be represented by a chemical formula because the constituents are not added in any ratio by mass. There's no particular ratio they follow. Am I communicating? I told you, I said something before in this class that chemical formula, component element of a chemical formula must have a must be combined in a fixed ratio. Am I communicating? Now, but for a mixture, the constituent which must not be an element, simply say the constituent. The constituent of a mixture are not added together in any particular ratio by mass. So a mixture cannot be represented by a chemical formula because its constituents cannot be added together in any particular ratio by mass. That's why you cannot represent them with a chemical formula. Now, can you represent a flood water with a chemical formula? Can you represent sugar dissolved in water with a chemical formula? So you say yes. How? You cannot, because there is no chemical reaction between them. They are not combined chemically, so you cannot represent them with chemical what? Each of them will maintain their chemical formula. Am I communicating? Each of them will maintain their what? Chemical formula. The only relationship between components of a mixture is physical property, physical relationship, like dissolution. Dissolving is a physical process. Two of us, it can dissolve, but it will not form a compound. It will remain salt. It will remain salt. It won't change if you dissolve it in water. Are we together? Now let's go over to compound. A compound can always be represented by a chemical formula. A compound can always be represented by a chemical formula. Do you know why? The reason is because the component element, the component or simply component, but it must not be only elements. Just simply say the components. The component of a what? Compound. The component of a compound are present in a fixed what? Ratio by mass. They have a fixed what? Ratio by what? Mass. That's why if you have water, this is water. This is water. The component element of water are what? Hydrogen and what? Oxygen. And they must combine for water to be formed. Hydrogen and oxygen must be combined in ratio of what? 2 is to what? 1. If you see anything that is not where hydrogen and oxygen are not combined in ratio of 2 is to 1, run away. That thing is not water. Hello? That thing is not what? Water. That's why I say that's why this is a compound, because that's why also it's a compound, because it has a fixed ratio in which they combine by mass, and it can be represented in a chemical what? Formula, because there's a ratio of combination between the components. Are we together? But you cannot find this. You cannot find this in what? Mixture, because the components of mixture are not chemically bound together. They are just physically staying together physically, and can be separated by physical what? Means. That's why we employ separation techniques to separate them based on a physical relationship. But you cannot use this thing to separate. You cannot use these separation techniques to separate components of a compound. It's not possible, because the compound has combined together to form a what? The element components have come together to form a new substance. Are we together? Are we together? Now look at water now. Hydrogen, gas, oxygen, gas combine to form what? Water. The ratio of what? 2 is to what? 1. You want to balance the equation now. Here becomes what? Here becomes what? 2, right? And here becomes what? 2, right? Here becomes what? 2. Hydrogen is what? There's no 2 in front of oxygen. Sorry. Hydrogen is what? 1, 2, 4. 1, 2, 4. Oxygen is what? 2. There's 2 in front of water. Then oxygen is what? 2 here. If you watch, the compound formed is what? Water. Water has entirely different properties from properties of what? Hydrogen and what? Oxygen. Because it's entirely new what? Substance. You can drink water. Go and drink hydrogen. Can you drink hydrogen? I don't know if I'm getting it. They have different properties. Properties of a compound differ from the properties of each component what? Elements. Are we together? Now let's go to the next difference. Now if you want to determine, okay, let me just put this down before I explain. The properties of a mixture. The properties of a mixture are the sum of the properties of its constituents. The properties of the mixture are the sum of the properties of the individual constituents. Properties of a mixture are the sum of the properties of what? The individual what? Constituent. Are we together? Are we together? Constituents. Okay. Now let's go over to compound. But the properties of a compound differ entirely from those of the what? From the properties of each component what? Element. The properties of a compound differ entirely from the properties of each individual what? Each component what? Elements. Are we together? Properties of a compound differ entirely from the properties of each component what? Elements. Because it's an entirely new substance. Are we together? Okay. So if you are asked now to state the differences between compound and what? Mixture, you can do that, right? Good. All right, let's answer this question here and now before we continue. It's not an assignment, we're answering it here, okay? Before we continue, put it down. Which of the following is an example of a chemical change? Which of the following is an example of a chemical change? A. Dissolution of salt in water. B. Rusting of iron. C. Melting of ice. D. Separation of a mixture by distillation. Children, what's the answer? B is what? Is what? A chemical change.
Yes.
Festus, what's the answer? You, what's the answer? Is Chugu? What's the answer? Rusting of what? Iron. Do you agree? Good. Number 2. Addition of water to calcium oxide leads to. Addition of water to calcium oxide leads to A physical change. B. A chemical change. C. The formation of a mixture. D. An endothermic change. Oh yeah, Izuchukwu, what's the answer? And what? Endothermic change. What's the answer? You can answer the question. You should be able to understand what if you add water to where. You should be able to know what it means before you can answer the question. If you don't know what it means, you cannot answer the question. Chinwe. Why chemical change? What is the name of that? What is the name of that new substance? If you calcium what? Peroxide. You call him a chemical blunder. In fact, I will sentence you to 20 years in chemical prison. Festus. Hey, Festus, I asked her because she got the answer, but I'm not happy. I want you to explain. Hey, from where? How can you add water to calcium oxide and you get calcium? Where did nitrogen come from? Nitrogen. Calcium solution. Who will save us here? You got the answer, but I am not comfortable with it. Who will save us here? What is formula? What is chemical? Even though we have not done chemical formula, but what is chemical formula for calcium oxide first? What is chemical formula for calcium oxide? A what? C what? Ca. Ca what? Cao. I agree. This is calcium what? Oxide. What is another name for calcium oxide? Soda kwa? Please, whenever you hear soda, know that there's sodium there. It's not soda. It doesn't concern soda. Limestone, calcium tricarbonate 4. See limestone here. Calcium tricarbonate 4 is what? Limestone. Slake lime. Slake lime is calcium hydroxide. See slake lime here. Slake lime is calcium hydroxide. Slaked what? You are missing it. You are getting there, boss. You are missing it. Quick lime. This is what? Quick what? Quick what? Quick what? Lime. Now, this when you add water into this, see what we formed. What do you think we formed? Slake lime now. Calcium what? Hydroxide we formed. So if you add water to quick lime, you form a slake lime. So we call it slaking of lime. It becomes slaked. Now this slake lime, is it a physical change or a chemical change? The answer is what? Chemical change. I just explained the answer now. Don't worry, you get there, okay? Keep studying. Keep studying. I seriously want you guys to study. Please remove any form of distraction. Study. It will flow in. If you stand, you will be rapping. It's not magic. Okay? You know it. You know it. You have to burn your candle. Burn candle. Don't waste your time. Study, please. This is the time you have to do that. So the answer to that question is what? Chemical what? Change. Now, number 3. Hope you're putting down all these things. I call them nuggets. I call them bullets. These things are weapons. These things will form you. These things will help you in chemistry. These things I'm dropping here, pick them. I know why if I talk about something, I want to talk about some things about it, because so that some of you may just stay here till September and they go back to school. So that at least by the time you go back to school, you would have grabbed some things. That's why I teach like this. Talk about it. We bring it out. Even though we have not done this, we'll still do it as a topic, but I just want you to know that such thing exists, okay? So that whenever you hear such thing, you will not be confused. Now, the question 3 says, which of the following is a physical change? Which of the following is a physical change? A. Freezing ice cream. Freezing ice what? Ice what? cream. B, dissolving calcium in water. B, dissolving calcium in what? Water. Dissolving calcium in what? Water. Is this equation balanced? This equation for slaking of lime, is it balanced? Is it balanced? What is not balanced there? Huh? It's balanced. True of us. All right. Let's continue. B is what? Dissolving of calcium in what? Water. C is what? Burning kerosene. Burning what? Kerosene. Burning what? Kerosene. D is what? Exposing white phosphorus to air. D is what? Exposing white phosphorus to what? Air. Exposing white phosphorus to what? Air. All right. What's the answer? Festus. What's the answer? Festus. Huh? Freezing of ice cream. The other ones are what? Chemical change, because new substance are formed. But this one is a physical change. If you freeze that ice cream, if it becomes ice block, if it blocks, if you test it, will it still test ice cream? But that's where you will enjoy it more, sir. True of us. True of us. Now, if you bring it out and keep it on this table for like 1 hour, 2 hours, it will do what? Melt. It will still contain the what? Ice cream. So it's a physical what? Change. So that's the answer. The answer is physical change. Number 4. A chemical reaction is always associated with. A chemical reaction is always associated with. A chemical reaction is always associated with. A. Are we together? Right. A chemical reaction is always associated with A. An increase in the composition of one of the substances. An increase in the composition of one of the substances. B. A change in the volume of the reactant. B. A change in the volume of the reactants. C. A change in the nature of the reactants. C. A change in the nature of the reactants. D. The formation of what? New substances. D. The formation of what? New substances. What is the answer? Chinwe. Is what? D. D. Option A says what? What's the question again?
A chemical reaction
always. Look at the question, please. Why? Please, hello. Please, why answering question? China, are you listening? Why answering question? Please calm down and understand the question. The question says what again?
A chemical reaction is always associated.
Is always. What it means is that anytime a chemical reaction takes place, these things must happen. That's what the question means. Always. Option A is what?
Increase in composition of one of the substances.
Increase in composition. There must not always be what? Increase. Am I correct? In fact, once the reactants react, they are gone. Some new substances, true of us, they are not like, so that is not the what? Option. Option B says what?
A change in the volume of the reactants.
Is it all the reactant that you check the volume? Is it not only the liquid or gaseous one? Must you always, is there anything like volume of solid reactant? We talk of their words, mass, right? I've not seen that it's not always. Be careful about the way you answer questions. So that is not the what? Answer. Option C is what?
A change in the nature of the reactants.
Is it like that? The nature of reactant is their nature. They will not change. True or false? Reactant is the reactant. So they are nothing like that. So that is not the option.
Formation of new substance.
Good. No matter anytime a chemical reaction occurs, new substance is a must be what? Formed. If not, then that is not a chemical reaction. True or false? True or false? Good. So the correct option is what? D. Now, the next question says, a heterogeneous mixture, the one I will just discussed today. Let me know those that we are attentive in a class. A heterogeneous mixture can be defined as any mixture A heterogeneous mixture can be defined as any mixture, A, whose composition is uniform. Whose composition is uniform. B, whose composition is not uniform. B, whose composition is not uniform. C, formed by solids and liquids. C, formed by solids and liquids. D, of a solute and a solvent. D, of a solute and a solvent. D, of a solute and a solvent. If you are not careful, you will fail this question. Let me know whether you truly understood what we've been talking about. Oya, Chinaya, what is the answer?
That whose composition is not uniform.
Call the question again.
A heterogeneous mixture.
A what?
A heterogeneous mixture can be defined as any mixture. A whose composition is uniform. B, whose composition is not uniform.
Have you not seen? Have you seen how she's answering questions? This white people. I want you to understand what you are doing. I'm teaching you how to answer questions. That's why I do things like this. I will teach you. You learn it. Then also teach you how to answer questions in case you find yourself in exam hall. Have you seen how she just look at first option A, look at first option B, and conclude? I concluded. Hello. Email fan jam. Don't rush. You see why has started this kind of thing, sir. Calm down, don't rush. Look at the option very well. Sometimes options may look alike. Sometimes option may even be correct in a way. In a way. But the most appropriate one is with what is the one you do what? Choose. So don't just rush and start answering. Go through the options properly. Option A says what?
Whose composition is uniform.
Now let's analyze this. When the composition of a particular mixture is uniform, that mixture is what? Homogeneous. So is that the answer? Then go to the next. Don't just choose. Just have it in your mind. Go to the next option.
Whose composition is not uniform.
What is heterogeneous mixture? Is composition? I think I mentioned this word, uniform, right? Are not uniform. Heterogeneous mixture. The composition are not what? Are not what? Uniform. I agree, but calm down, auntie. Go down to the other options. The second option. The third option is what?
Formed by solid and liquid.
formed by solid and liquid. Now, I want you to understand something now. Is it possible for a heterogeneous mixture to be formed by liquid and solid? Yes. Do you now understand it now? Why you should look at the options? Now look at it now. Yes, a heterogeneous mixture can be formed by what? Solid and liquid. But do you know why that is not the answer? Because it's not every solid and liquid form a heterogeneous mixture. True of us? A solid and liquid can form. If you get powder, your powder, the powder you rub on your face, or starch. Let me say your powder self. You rub on your face and put it in water. Will it dissolve? Will it dissolve? That mixture is heterogeneous. Is powder not solid? Is water not liquid? But the option say solid and liquid. Yes, solid and liquid can form a heterogeneous mixture, but not all heterogeneous mixture are formed by what? Solid and what? Liquid. True of us. And not all solid and liquid form a heterogeneous mixture. Some solid and liquid, if you beat them, they can form a homogeneous mixture. Like salt and water. They form a homogeneous mixture. Have you seen why this option is not correct? But truly, solid and liquid can form a heterogeneous mixture. But it's not the correct answer. I don't know if you understand what I'm saying. Choose the most appropriate option. Be careful, don't rush to options. So that is not the what? Answer. The next one is what?
Of a solid and a solvent.
Of a mixture of a solute and this one is out of the case because there's no a solute will always dissolve in solvent, true of us, to form what? A solution, which is a homogeneous what? Mixture. But if you're not careful, this C and B can confuse you. Hello? Confused. So B is more appropriate than what? C. Are we together? Now let's assume that there's how they did it. Option C, B is not there. Let's assume that option B is not there, and you must choose an option there. Don't you think that C may be the likely answer you may take? True of us, because truly solid and liquid can form a what? Even though it's not that correct, but if you must choose like now, if they ask to choose the most appropriate from the remaining three, that solid liquid so that is more appropriate. But even though it's wrong, but it's more what? Appropriate. Am I communicating? So please be careful on how you answer question. So the answer to this question is what? That the composition is not what? Is not what? Uniform. Good. Now, the next question. Which of the following substances is not a homogeneous mixture? Which of the following substances is not a homogeneous mixture? A. Filtered seawater. A. Filtered seawater. B. Soft drink. B. Soft drink. C. Flood water. C. Flood water. D. Writing ink. D. Writing ink. What's the answer? C is what? Flood water. I think I explained this, right? It's flood water. Seawater, filtered one. But how do you mean they didn't put filtered in seawater? You will take what? Let's say they put that filter in flood water and leave the seawater without filter. Which one is the answer? See what I write. Right. So the answer is what? If you filter it, it will be. If you filter it, you will get a homogeneous mixture. Even if there's anything inside it, it will dissolve in it. True of us. So soft drink is a. If you go to market, if you go to this shop now to buy Coke, and you open the Coke and you drink it, and in your mouth you start feeling sand. Will it drink it? You say no, this one is not good. Two of us, or you see particles inside the dancing, and we know inside the Coke. Will you drink it? No, that one is different. That one is different. They allow that thing inside it to prove to you that it's natural. You know, they say it's natural, right? If they say it's natural and you don't see such thing, they leave it there intentionally to prove to you. That's what they say. Even though there may be other components, but at least they use orange. They leave it there for you to prove to you that at least they use orange, even though it may not be 100%. I don't know whether it's 100%, but all I know is that they actually use what? Orange. They did not use color or flavor. They don't use orange flavor. By virtue of that fiber being there, means that they actually use what? Orange. Only God knows whether they use it completely or not throughout. But at least there's orange in it. That's what they leave it for you to prove to you.
What if they now use only the fiber and put inside?
How? Where would they get the fiber from? Does it make sense? No. Tell me now. No, you go and buy orange. Then you lick the orange. Then get fiber and put. How many? Do you know how many bottles they produce a day? Do you know thousands, millions of bottles that will serve the whole Nigeria? No. Think about it now. Wait, now be realistic. Do you know how many millions of bottles they produce to be able to reach you here? There is any place you go in this country, you will not see it. See, I'm not just a lecturer. I have worked in different places. I've worked in manufacturing this where they produce most of these things, drugs, what have you. I know what it means. Any product you see, you go to this place, you see. You go to this place, you see. You travel to Enugu, you see it. You go to your village, you see it. Do you know how many millions they produce it to be able to get to those places? Now, you tell me that they will go and buy. Do you know how many millions of oranges they will buy? Then they will buy it and they'll sit down and lick it. Now, be realistic, please. Be realistic, please. All I know is that they use what? Orange. But I don't know whether it is total. It's only orange they add there. But all I know is at least they use orange. For you to be able to drink that bottle and feed that thing. I'm not communicating. They use orange. It's a fact. But what I cannot prove to you is that whether they use orange 100% or whether they just put small and other things. I don't know about that one. But what I'm sure, I will beat my chest that they use what? They can never get orange, peel it in and throw it away. Then what did they get? No, they give you and peel it and pour it away and then use the fiber. They don't use fiber and color and flavor. Hey, realistic now. Doesn't make sense to you. Even you said doesn't make sense. It doesn't make sense. Now, so flood water, writing ink. These ones are homogeneous mixture. If the ink you are using to write has particles inside it, it will block it. True of us. It will block that. It will come out. Your pen will stop writing. True of us. So those ones are homogeneous. What? So the answer is what? Flood water. Now, the next question says, the dissolution of common salts. The dissolution of common salt in water is a physical change because the dissolution of common salt in water is a physical change because the salt can be obtained by crystallization. The salt can be obtained by what? Crystallization. B. The salt can be recovered by the evaporation of the water. The salt can be recovered by the evaporation of the water. C. Heat is not generated during mixing. Heat is not generated during mixing. D. The solution will not boil at 100 degrees Celsius. D. The solution will not boil at 100 degrees Celsius. All right, what's the answer? The solution will not boil at 100 degrees Celsius. So what's the answer?
B.
B is what?
The salt can be recovered by evaporation of the water.
Do you agree with her that the answer is B? And the salt can be recovered by evaporation by water. Do you agree with her? Please look at the option very well before you conclude. Option A. The salt can be obtained by crystallization. The salt can be obtained by crystallization. Chinaya, do you agree with Chiwendo? C is what? By the mixture. It's not what I detected though. I say heat is not generated during mixing. C, heat is not generated during mixing. That's what I said. Do you agree with her? What's the answer? D is what?
The solution will not boil at 100 degrees Celsius.
What is the answer? Is what? B is what? I thought she said you do not agree with Chiwendo. It's Chiwendo I ask you about, not Chinaya. Festus. D. Chinaya, why do you say D?
For example, like water. Water, it's near rice like that. What the is, oh yeah, do well, right? Oh yeah, do well, more water. Oh yeah, do boil them, we are rice or beans. So, due to that, it's another substance inside. Oh, you make good water. So, for the water to boil, it takes time. I boil.
I agree with you. You are right. What you said is correct. Be careful the way you answer question. Yes, a mixture is not a pure substance. Three of us, we said it. A mixture will boil at a higher what? Temperature. I agree. But they just brought something that has no business with the question. Taking option. Can you confuse? So they can confuse you. Yes, it's true. I agree that it will boil at a what? A temperature higher than what? 100 but it's not. But that is not the answer, even though it's true. But that is not the what answer. It has no business with the what question. Am I communicating? Even though it's correct, what he said is true, but it's not the what answer. The answer is B. You can recover the salt by what? Crystallization. By what? Sorry, evaporation. If you get salt and put in water, it will dissolve. We did this in our. Okay, you were not there. Okay, you don't come there now, child. You're missing no. We did it in what? Our what? Solubility in the other center, right? When we talked about we just carry out a short experiment on how to determine solubility, right? You say that you add water. If you dissolve salt in water and heat it, the water will do what? Evaporate. And we also gave an instance on how they produce salt. Our common salt we know is sodium what? Chloride. True of us. We gave instances like now there's a part of the world where they have when the sea they will pump close to sea water. This is how they produce this sodium chloride you are seeing. Some part of the world they will pump sea water to the ground, to the bank of the water, the sea. They pump the sea water. The sea water will come because the sea water has sodium chloride inside it. It's more of a solution. They pump it. That's why it tastes salt. They pump water on the land close to the water, the bank there. Having pumped the water because the water will dry, the water will evaporate under heat of the sun. Then what will remain on the ground is what? Sodium chloride. They will now pack it and do other things they want to do there. Either they will now take it to the factory. They will now add other things like maybe to prevent goiter. They will start adding other things like iodine. That's why they say they have iodized what? Salt to prevent what? Goiter and other things. But the main source, most of these places, they get it from this what? From the sea water. Am I communicating? Now, this is what happened. So, the point there is that not evaporation? Even though the heat came from the what? Sun, right? But you can also carry out the same evaporation by mixing salt and water and putting the solution, the sodium chloride solution in a dish, in an evaporating dish, and heat it. The water will do what? Evaporate. What will remain in the dish will be what? Sodium chloride. Have you not separated them? Have you not? Don't worry, we'll still do in our next chemistry class here. We enter what? Separation techniques. That's when you understand what this I said well. There we also explain crystallization. If you watch now, why I'm going back to question things we have done so far in the question format, so to refresh our memory on those things we have done. Then in our next class, we enter what? Separation what? Techniques. Now, so the answer is what? The answer is what? Good, B. So is it a physical change? Yes, that is a physical change because it can be what? Good. Let's continue. I think we have answered this question before. Is there any question I gave you that contains vulcanizer solution? Assignment I gave you, right? I think we have done the assignment. The one that contains petroleum, vulcanizer solution, carbon 2 sulfide, right? Right? I gave it to you as an assignment, right? So I don't repeat it again.
So I just listed out.
Did I give you a assignment when I say, well, okay, what did it, okay.
Which of the following substances is a mixture? Substances.
So what did I list?
Granulated sugar, seawater, sodium chloride, iron binding. sulfur powder, distilled water, ethanol, sand, bronze, washing soda, common salt, blood, rubber latex, anionizer solution, carbon, two sulfur.
Did I mention petroleum? Petroleum is petroleum a mixture? Yes, because the component can be separated. It's a mixture. Petroleum has a lot of things inside it. The component can be what? Separated. By the time we do fractional distillation, you understand that petroleum is a mixture. If not, why do we obtain bitumen, name them, kerosene, all those things? Why do we obtain it from petroleum? Petroleum is crude oil. Petrol is that one we call, what is it called? The one you call fuel now. Premium motor spirit, you call fuel. But petroleum itself is the crude oil that you refine using fractional distillation to get different components. So it's a what? It's a mixture. Are you together? Are you okay? It's a mixture. Okay, another question is I gave you the one that contains distilled water, ethanol, right? Bronze, right? Okay. Any question? Any question? Any question? No question. Okay. Okay, assignments. Number 1. Classify each of the following changes as either a physical or chemical change. Classify each of the following changes as either a physical or a chemical change. A. Addition of water to quicklime. Addition of water to what? Quicklime. In brackets, slaking of lime. Slaking of lime. To quicklime. In brackets, slaking of lime. Slaking. B. Melting of candle wax. The melting of candle wax. Candle. C. The change in color of zinc oxide. The change in color of zinc oxide from white to yellow and vice versa. During heating and after cooling respectively. The change in color of zinc oxide from white to yellow and vice versa during heating and after cooling respectively. D. The dissolution of copper in concentrated triosonitrate 5 acid. The dissolution of copper. The dissolution of copper. Please, if you miss out, please let me know. Don't keep quiet, please. The dissolution of copper in concentrated triazonitrate 5 acid. The dissolution of water in concentrated triazonitrate 5 acid. Conc trioxonitrate 5 acid. E. The dissolution of common salt in water. E. The dissolution of common salt in water. F. The hardening of cement by the absorption of carbon 4 oxide. The hardening, see the spelling here. The hardening of cement by the absorption of carbon 4 oxide. Assignment number 2. Define the terms. You write the assignment in detail in your notebook. Define the terms. Mixture and the compound. So after defining mixture, you define what? Compound. So do research and give me a comprehensive definition. Okay? Make sure you understand it because we are going to present it here in our next class. In our next chemistry class. Define the terms mixture and what? Compound. That is, this one is what? AI. Are you together? A what? I. Okay? Then AII. Give 3 differences between a mixture and a compound. Give 3 differences between a mixture and what? A compound. Number 2A says define the terms mixture and compound. That is, 2A what? I. Okay. Then 2A AII says classify the following substances. Give 3 differences between a compound and a what? A mixture. Then B says, that is 2B, right? Are we together? B part of number 2 says classify the following substances. Remember classification of matter. Remember, okay? Classify the following substances as an element, a mixture, or a compound. Classify the following substances as an element, a mixture, or a compound. Then limestone. 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 I sleeping? Huh? I sleeping? Diamond. Diamond. Sand. Sand. IV. Soil. Soil. V. Urine. Urine. VI. Bronze. Bronze. VII. Sugar. Sugar. VIII. Gold. Gold. IX, clay. IX, clay. X, urea. X, urea. XI, antimony. XI, antimony. ANTIMONY. XI, antimony. XII, soap. XII, soap. XIII, milk. XIII, milk. XIV, air. XIV, air. XV, neon. NEON. XV, neon. And neon. Don't what you know what is neon now? Then XVI, iron. Iron. XVI, iron. Then number 2C. Number 2C, why is sodium chloride regarded as a mixture? Sorry, why is sodium chloride solution, not sodium chloride? Why is sodium chloride solution regarded as a mixture? All right, question number 3. Which is the odd one out? Odd, as odd one out. ODD, then put hyphen, then out. Which is the odd one out? Odd one out. You know what I mean by odd one out? Which is the odd one out? A, air. A, air. B, urine. C, brass. 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 D, sand. Number 4, right? All right, number, how many questions have we? Okay, in the 4th one. One of these is not a chemical change. One of these is not a chemical change. A, rusting. B, sublimation of solids. Sublimation, SUBLIMATION. Sublimation, SUBLIMATION. Sublimation. Slaking of quicklime. Slaking of quicklime. Slaking of quicklime. Fermentation of glucose. Fermentation of glucose. Now let's go over to question 5. One of these professions, one of these professions has no need for chemistry. One of these professions has, because we are talking about one, right? Has no need for chemistry. A, please, that profession, please write one of these professionals, okay? One of these professionals. Don't stop at profession. Just completely one of these professionals, okay? A, miners. A, miners. B, engineers. C, philosophers. D, geologists. D, geologists. Question number 6. Chemical changes around us include all except chemical changes around us include all except A, rusting of iron nails. Into rusting of iron nails. B, fading of colored clothes. Fading of colored clothes. You understand that, right? C, sieving. C, sieving. C, sieving. D, decomposing of green leaves in a compost. Decomposing of green leaves in a compost. Number 7. Number 7. Which of the following statements is incorrect? Which of the following statements is incorrect? A, the addition of water to quicklime is an example of a physical change. The addition of water to quicklime is an example of a physical change. B, a chemical change is irreversible and a new substance is formed. A chemical change is irreversible and a new substance is formed. C, a physical change. A physical change can easily be reversed and no new substances are formed. A physical change can easily be reversed and no new substances are formed. D, separating a mixture by distillation is an example of a physical change. Separating a mixture by distillation is an example of a physical change. Separating a mixture by distillation is an example of a physical change. Number 8, right? Which of the following substances is a mixture? Is it number 9? I'm asking everybody. It's 8, not 9. Check your numbering. Are you sure you didn't call those A, B, C a separate number? Check well. It's 8, right? Number 8. Which of the following substances is a mixture? A. Sulfur powder. A. Sulfur powder. B. Bronze. B. Bronze. C. Distilled water. C. Distilled water. D. Ethanol. D. Ethanol. For the benefit of those that join us newly, I want to repeat this assignment again so they can benefit from it. All right, last but not the least, question number 9. Question number 9. Which of the following are mixture? Which of the following are mixture? I. Petroleum. I. Petroleum. I. Rubber latex. I. Rubber latex. I. Vulcanizer's solution. I. Vulcanizer's solution. IV. Carbon 2 sulfide. IV carbon 2 sulfide. IV carbon 2 sulfide. Then option A. Option A. Option A. Okay, what's that? It shock you? Those ones, I will explain to you how to answer questions like this. Okay, just write what we are doing. Thank God I even because the way your face look like, it seems you have never answered a question in this form. Don't worry, I will teach you how to answer a question like this. Option A. Is it what? Is it what? That it can confuse people. Not everyone knows how to answer a question like that. Okay, A. Option A. I, and I. Option B. I, and IV. Option C. I and I. Option C. I and I. Option D. Option D. I and IV. Option D. I and IV. Now let me teach you how to answer this type of question. Look at it. Look up. If you see a question like this, let me use this question as an example now. They ask which of the following are mixture. They listed from I to IV. They listed different substances. But what it means is that look at these substances. Let's assume that it is let's assume that it is I. Those ones are mixture. You look for the option and choose the option that has what? I. Is it clear? So this is how to answer question like this. So don't get confused whenever you see a question like this. So these are the assignments. This is the assignment you will do in our next chemistry class here. That means next week, what? Friday. We will look at these assignments and we'll review it in our chemistry class. 2 people came late. So tell us what you did. Let's use 5 minutes to listen to you. Come out here. Oh yeah, tell us what you did in the assignment I gave, vulcanizer solution. You just come out. Yeah, you are focusing. Come out. Yes, read. We want to see what you read. Read what you did.
Vulcanizer solution. This is a chemical mixture. This chemical mixture usually has sulfur or other cross-linking agents, accelerators, and activators. The main job of the vulcanizer solution is to start and speed up the process of vulcanization. When mixed with rubber.
Did you better to look up the meaning of vulcanization?
Yes.
What is vulcanization?
So when mixed with rubber latex cross-linking agent makes chemical bond between the rubber molecule. This makes the structure more stable and resilient. Special agents are added to enhance bond strength and improve ozone resistance.
You better to check what is vulcanization?
It's a process. I don't know right about.
You should have written it somewhere in your note. And then what? Can you bring it down to practical what you see around us? Can you explain using what you see around us of organization?
Like any use here, like in bounding, like molding of rubber. It will mold the so you make the rubber flexible, resistant to melt that so easily.
I continue. I don't.
No.
Okay.
So I wrote here, accelerators and activators in the vulcanizer solution help speed up and control the vulcanization process, ensuring that the desired properties are reached. Then, the component of vulcanizer solution, I have petroleum, rubber latex, and vulcanizer solution. These ingredients are used.
You say what again? What is it?
Like how I wrote this.
What are components of vulcanization? Read again. Let me hear what you say. What petroleum?
I said petroleum, rubber latex, and vulcanizer solution.
What are you even saying?
Like sir, no sir, wait. Like in the
please cancel that thing you wrote. Cancel that component. Cancel it, bro.
Okay, I should cancel.
Cancel that component you wrote. Go back and check what are the components of organization. Cancel that thing you wrote.
Yeah, go with them, sure.
Because before you go and make mistake with it, cancel it, okay? Did you do any other thing? Is that all?
Then use this.
Okay, use it. What is it used for?
They are used for rubber molding.
Okay.
It is used to enhance bond strength and improve ozone resistance. Then it is also suitable in a press or autoclave bonding application. In general rubber molding. Then vulcanizer solution. Okay. Okay, say that we should check whether vulcanizer solution is it a mixture element, so it's a chemical mixture which comprises
Of what?
phosphorus,
Phosphorus,
sulfur, benzene, and rubber.
So-
Number one.
Continue. Continue.
Sir, I don't finish.
I don't.
Yes,
So where did you get that you called before?
Google.
Google.
Yes.
The vulcanizer solution contain vulcanizer solution.
That's why I also wrote this one. So say this one is wrong. This one
Please
must be
cancel that first one, okay?
right. Okay, sir.
All right, thank you. Please, last person, please. No time to waste. Fast. Okay.
Meaning of vulcanizer.
Please, louder. Okay. Can you hear her? We cannot hear you. Louder, please.
Meaning of vulcanizer.
That is a wrong way to represent.
Okay.
Stay away. No, your hand should be ahead.
It is a machine for vulcanizing various rubber and plastic products.
Machine?
Yes.
Vulcanizer solution.
No, I start with meaning of vulcanizer.
Okay, vulcanizer. Okay.
Yes.
Okay. Sorry. It's what?
It is a machine for vulcanizing various rubber and plastic products. It has the functions of timing, mode clapping, automatic pressure supplementation, automatic temperature control, automatic timing, and alarm when it arrives. The meaning of vulcanizing solution. It is formulated as a liquid vulcanizing agent suitable for rubber bonding purposes. It is a mixture that usually has sulfur, accelerators, and activators. The main job of the vulcanizer solution is to start and speed up the process of vulcanization. That is the component of vulcanizer solution. We have phosphorus, we have rubber, benzene, and sulfur. Uses of vulcanizer solution. It is used to improve the properties of rubber materials. The mixing petrol, rubber, latex, and vulcanizer solution makes rubber products stronger, more flexible, and more resistant to wear and tear.
Is that all?
Yes.
Thank you. Please, I want us also, the way we did this assignment, let us do the one I gave today. Research on it. By the time you understand what you are doing here, if it becomes part of you, that's when you appreciate what you are doing here. Please ensure you create time to do these things. You appreciate it, you understand it better. Just give yourself 1 month, you change automatically, academically, you'll be a different person. So please take it seriously. It's late already. I think we'll stop here. Any question? All right, thank you very much. See you tomorrow. Tomorrow's lesson. I told you that we have entrance exam here. And because of that, we will not start in the morning tomorrow. And exam highest, I think. Okay, you want us to start about 2 o'clock? No. We can't. Exam will start by 10. 1 hour exam, and we'll mark it immediately. So let's say. See, tomorrow's lesson, let's fix it. Okay, highest, 11 we are done. Then marking, 1 hour, 12, and done, 1, before we get there. 2 o'clock, So tomorrow lecture will start from when? 2 o'clock. So I'll try to speed up things here so that I'll be there by 2 o'clock, okay? All right. See you then. Please do your try to collect assignment from him, so you will to prepare yourself against tomorrow.